we're going to be doing. We are going to find the exact value of the logs without using a calculator. Okay, so what we're going to do first is we're going to set this equal. You can actually set it equal to anything. I'm going to say y for the time being, but if you put b or m or n, it's just a variable. Okay. The convenience of doing this is that now we can change forms and we have a variable as a reference. So that's the only reason why we're doing it. Okay. Anytime, and this bodes for any form that you're in. If you are trying to solve a log expression, an exponential expression, one of the first things that you want to attempt to do is, if you are unable to get the answer right away, is to change forms. Okay, it's a really simple way to solve things, if possible. So in this case, we're in log form. We're like, I don't know what log base 2 of 16 is. However, if we change forms, what's the base here? 2, what's the exponent? And then it equals 16. Now 16 can be written as a number as a base to an exponent. Do you guys know what that is? 16 is what to what power? 2 to the 4th. All right. Now the convenience of having the same base here, all right, is if we have the same base to a power and they are equal, what do we know about the exponents? They have to be the same. Does everybody agree? So 2 to the y equals 2 to the 4th. And what does y have to be? It has to be 4. So y equals 4. So in terms right now, for what we know, we would have to give you numbers where the bases are the same because we don't have strategies beyond that at this point. So for the next 3 examples, our goal is to rewrite and get both expressions around the equal sign to have the same base. That is going to be the goal. And when you do that, then you can just set the exponents equal to each other and solve. So if we take a look at this next one, again, we're going to set this just equal to y as a variable reference. All right. And then what is the base here? 3. What's the exponent? Y equals 1 over 27. Now 1 over 27 is 1 over, 27 can be written as 3 to the 3rd. Now if I have 1 over some number, how can I switch it so that 3 is on top? So this becomes 3 to the negative 3rd. These are equivalent statements here. Okay, so anytime you have a fraction, you want to kind of remember that little trick of changing it to a negative exponent. So now what we have here is we have 3 to the y equals 3 to the negative 3rd. So if the bases are the same, then the exponents have to be the same. So our final answer, y has to be negative 3. And in this case, our y is the expression we started with. So log base 3 of 1 over 27 is negative 3. What's the base here? 1/4 exponent equals 4,096. Again, if you had no calculator, it's very unlikely we're going to give you a number so big. How can we rewrite 1/4? 4 to the negative 1, but because we have the y, this is going to be 4 to the negative y. Great. And then anybody know 4,096? It's 4 to what power? What is it? 4 to the 6th. So now I have negative y equals 6, which means that y must equal negative 6. How can we rewrite? Well, let's start here. What's the base? E, remember natural log, it really is log base e, so you do have to remember that. So we have e to the y equals the 8th root of e, but how do we rewrite the 8th root of e? E to the 1/8, good. All right, so now we have both bases e, set the exponents equal to each other, so y equals 1/8.